friction. It's air friction. Basically, it's a resistance to vertical motion. I guess technically it doesn't have to be vertical, but all the examples we're going to do are vertical. Technically, there is horizontal air resistance, but the horizontal air resistance is usually less impactful because it's small compared to the speed of the object, as opposed to in free fall, that's usually a much larger value. So free fall is usually where we see it more. But it is true for horizontal motion too. All these terms, terminal velocity, all that stuff will apply to horizontal motion too. That's why you don't have cars that go, millions of miles per hour. There's a limit as to how fast they can go, and part of that's air resistance. So air resistance or drag is basically air friction. It's resistance to that vertical motion. Terminal velocity. Terminal velocity is the speed of a falling object when air resistance equals gravity. Now, we need to talk a little bit more about what actually causes air resistance and how it works. We're not going to do that right here with the lab, but we'll get to that in a little bit. But here's what you need to know. Air resistance is not constant. It's not constant. And so as this value increases, at some point it equals gravity. And when they equal, we reach something called terminal velocity. A simpler way of thinking about it, it's when objects no longer speed up in free fall. So as an object falls, at some point in time, it stops accelerating. And at that point, it's called terminal velocity. Skydiving is a great example of this. Okay? As a person's falling, they're going to speed up until they reach terminal velocity, at which point they won't speed up anymore, and they're at that maximum speed. We'll talk about, so when we're going to get into what affects terminal velocity, we're going to introduce it here today. But when we get into the notes, I'm going to show you a video. You may have seen this. Yeah, you may not have. You guys are getting to the age where you might have been too little. I think it was in 2012, but I could have been wrong. That there was a guy who he holds the record for highest altitude to skydive from. He did skydiving literally from space. So he went up in a balloon into space, and he jumped out, and he was skydiving. And it's really dramatic. You can see where the air resistance is so small that basically the terminal velocity is almost infinite. And then you can see where all of a sudden he starts having air resistance, and it changes things a lot. Yeah.
Is that the one sponsored by Red Bull?
Yeah. Everything crazy sponsored by Red Bull.
I haven't seen the actual video, but I've seen a lot about it.
Yep. Yep. So we'll watch that, and we'll talk about because it's like I said, when you think about air resistance, it makes a whole bunch of sense what's going on as he's falling. Okay? Good. So here's what you guys are going to do first. Make a list of factors that may affect the drag and the terminal velocity on an object. So we're going to focus on terminal velocity.